The second practice of this exercise is to get the efficient frontier. Okay, efficient frontier, and you can read the chapters of the textbook to understand what efficient frontier is, but I rather let you do the construction first before I will lecture the concept of it. Okay, because after we've done all this work, you will know why there is an efficient frontier existing. All right, so this time our work is getting harder. You have 4 stocks instead of 2, and you have this 5 months of returns, and these are all samples, not population. So the first thing you're going to do is to get the expected return, which is the average. All right, and then you get the standard deviation. Okay, and then you just drag it all the way. Let me zoom in a little bit. So expected return and standard deviation, and right here you are looking at different portfolios. So you have 6 portfolios, 1 to 5 plus market portfolio. And the market portfolio basically is the one with the highest Sharpe ratio. Okay, so what is a Sharpe ratio? I can just move down this a little bit. So the Sharpe ratio is the expected return minus the risk-free rate. So let me set the risk-free rate as 4% here, minus 4%, and it's not going to change. So that's the T-bills rate divided by the standard deviation. It's like a risk premium over the risk measurement. Okay, so this one is a little too much. Okay, change it to this. Okay, change the format, then drag it all the way. As you can see, a different stock has a different Sharpe ratio, and then I will need to calculate everything here. From portfolio 1 all the way to the market portfolio, but I would like to calculate the market portfolio first. So how do I get the market portfolio? I will use the weights here, and then I will use the solver again to maximize the Sharpe ratio of the market portfolio. Okay, so how exactly do I do that? First of all, I will need to calculate the return for each month of the portfolio. All right, so I will use A's return times A's weight plus B's return times B's weights plus C's return times C's weights. But that's going to be a lot of work, and I don't like that. Okay, but I will show you the result first. Okay, even though I don't like this work, you don't need to repeat this portion. You don't need to do all these clicks to calculate the standard deviation of the portfolio. Okay, so that's the portfolio return for the first month. The easier way, which I want you guys to follow me to do, is the sum of product function. I will use all the returns of the stocks times all the weights of the stocks, and I will need to log the weights. So I will log this 2 cells, so the weights row, the entire weights row is locked. And then I will click on Control-Shift-Enter, 3 buttons. See, I will get the same result. The thing is, after I lock it, all the weights will be consistently used for the rest of the cells in the same column. Okay, you can see if I randomly pick a cell, they all use the same weights. All right, and then I just drag it all the way here. Since the middle data is missing, just delete those. You can see that the Sharpe ratio is 0.674 if I allocate equally of my assets to each stock. So stock A get a 25%, a quarter of my wealth, and stock B get a quarter, stock C, stock D, they all get a quarter. All right, and how do I get the portfolio Sharpe ratio maximized? So this time I will use the solver function. But before I do that, I want to make sure this sum of weights is a calculation. It's a formula based on the 4 weights from A to D. All right. So let me do solve, and this time I want to maximize. Okay, I want to maximize the Sharpe ratio of the portfolio. So click on this, maximize the Sharpe ratio by changing 4 weights. Okay, this entire row of weights. The constraint, I'm just deleting all the constraint here, but I have to make sure the sum of weights is 1. All right, I want to make sure the sum of weights is 1, not 50%, not 130%. Okay, make it equal to 1. All right, there is another button here, make unconstrained variables non-negative. I rather not touch that because I allow this weight to be negative. You may ask me, how can the weight be negative? The answer is short selling. So if you are short selling B, then B's weight will be negative, and then you get the cash up front, then you have more than 100% of your wealth to buy other stocks. Okay, so solve, hit on OK. So as you can see, the result worked, the whole process worked perfectly. I have the maximized Sharpe ratio at 0.839. So that happens when the weights are like this. So I put 57% of my assets in D, just like Warren Buffett put 47% of his money in Apple. And then the rest, they all have their portion, but they are more or less at certain percentages. Okay, and then let me work on portfolio 1. The portfolio 1 would give you the minimized variance or the minimized risk. So once again, I'm going to use a sum of product function, and I will use all the returns of the stocks times the weights. Okay, times the weights. All right, decrease the decimal. Okay, so this is my start point. And you can see I have already set up the sum of weights here. So what you need to do is to get a solver, and you're going to do it one more time, but this time you're going to minimize the portfolio standard deviation. Oh my God, I don't have a standard deviation ready yet. I'm sorry. So I'm going to do this. Just exit solver, just drag it just by 1 cell. Okay, just drag it by 1 cell. And now I have the standard deviation of the portfolio. That's my target. That's my objective. So my objective is to minimize this button. Okay, this standard deviation for portfolio 1. That's going to give me the portfolio with minimum variance. All right, by changing the weights here in portfolio 1. All right, and the constraint will be the sum of weights for all of them is exactly 1. I'm fully invested. Okay, I'm fully invested. 100% of my money are in this 4 stocks. Okay, and then I will hit solve. Click on OK. All right. So as you can see, B got negative weight. So that basically means I have to reduce B's stocks weights to 0, and then I need to short sell it. So when I short sell it, the B's weight is negative. So why do I need to do that? Because my goal is to minimize the portfolio variance, and that basically means the one with the highest risk. You see for B, the standard deviation is the highest compared to C, D, and A. All right, so I need to reduce B's weights in my portfolio even to a negative extent. Okay, so this part is done. And then I need to work on the rest of the portfolios. So what I will do here is to set the expected return. Okay, the expected return. The best I can do in terms of return, you can see that I have 4 returns from 4 stocks. The best I can do is B's return 11.02%, and that's the highest. That's the highest I can get. Okay, and then I will need to calculate the return for each month for portfolio 5, because this portfolio eventually will give the highest return. All right. So what I will do again is the same step. So it is A's weight times A's returns plus B's weight times B's returns, but I will use a sum of product function of the return row times the weight row. Okay, this is for the weights. Okay, this is all weights, and I need to log the weight row. Okay, the row of weights. Drag it down, get all the returns. Okay, and here's the thing. Well, this is the highest return. I don't want it to be here. I want it to be, number one, I want it to be down here. Okay, I had a portfolio target return. Okay, this is my target. And number two, well, you may not trust my visual count because in reality you may have a 30 or 40 stocks under your management, and you can't just read one from another. So the best thing you can do is to just use Excel max function to pick the highest return of from the stocks. Okay, well, that's going to give me the same result, but this is more sophisticated and more useful when you have a whole bunch of stocks. Okay, and this time I want to calculate the portfolio Sharpe ratio and everything, so I just drag everything all the way to portfolio 5. Okay, and you can see that this is my starting point right now based on the 25% weight or equal weight for each stock. My average return is not 11.02, it's not my target, it's 9.77%. And I need to use a solver again, one more time, I need to use a solver again to equalize the expected return of the portfolio by changing the weights in this row for portfolio 5. So the return here would be equal to the target return. Okay, so let me perform solver again. So this time, again, I need to minimize the portfolio risk. So I need to click on the portfolio risk. Okay, this cell for portfolio 5. And I need to change the weights in portfolio 5. Be careful, you need to pick the right row. And then my weights here, delete the previous setting. My weights would be, number one, I wanted the sum of the weights. I want the sum of the weights to be equal to 1. Number two, I want the expected return of the portfolio to be the target, the highest return of all the stocks which I picked. Okay? Does that mean I have to put 100% of my money in stock B, the one with the highest return? Let's see. Okay, upon clicking on OK, you will see that yes, I do have to put a lot of my money, 77% of my money in B, because that's how I get the highest return for the portfolio. But also I need to put money in A, and I need to short sell C and D. So I may have $25 in addition to $100 of my own money. So I have $125 to invest in A and B. All right. In that way, my portfolio risk could be minimized. You can see that this 15.39% is lower than B's standard deviation. Okay. So that means this portfolio 5 is better than B alone, even though they have the same return, which is at highest 11.02%. But portfolio 5 is better than B alone because the risk is lower.